previous days. So as a reminder, in order to factor a quadratic, your equation must be in standard form to start. So remember, standard form is ax squared plus bx plus c equals 0. We want to make sure it's in this specific order so it's easy to read. After we put it in standard form, we want to look for any GCFs to make our numbers smaller if we can. It's always easier to work with smaller numbers, so if we can take something out, we're going to do it at the very beginning. So looking at the first couple examples, we're just going to practice this step, putting in the standard form, factoring out a GCF. So if I look, this has values on both sides of the equal sign. We want everything to the left. So I'm going to move the 4 by using subtraction, right? Opposite operations. I'm going to move the 19b by addition, opposite operations, right? So the 4 and the 19 cancel, making 0 on the right. And then over here, nothing is going to combine. So I just have 5b squared plus 19b minus 4. So just putting in a standard form. Now I'm going to look for any GCFs, 5, 19, and 4. None of these have anything in common, so I am done. This is in standard form and in its simplest form. Okay. So next example, same idea. I want the right side to equal 0, so I'm going to add 30 minus 95x and do the same thing to both sides so it stays equal. Right side equals 0. And then over here, I want to make sure I put this in standard form. So x squared has to go first. So I'm going to put 40x squared in the front, then the minus 95x, then the plus 30 or my c. So that's what we need to be really careful with, making sure it goes in the correct order. Now I'm going to look for a GCF. So what do 40, 95, and 30 all have in common? That would be a 5. So that means I'm going to divide everything by 5, right? That 5 is going to come out front, and I have 8x squared minus 19x plus 6. So I want to double check if that wasn't the GCF 5, I would be able to look at these and see something else that comes out. So for example, 8 and 6 both have a 2 in common still, but because 19 doesn't, everything is factored out. If there was something still in common, that would just mean I didn't take out the greatest number, so I would go back and try again with something bigger. Now, something we do want to be careful about when we get into some harder problems, it's usually just because there's multiple things on either side. So when we rewrite, we're going to have to combine some like terms. So for example, I have a 1 on this side, and I need to subtract it to make it 0 over here, and I want to line it up with its already like term on the left-hand side. Same idea with this 3n squared. I'm going to add, and I want to line it up with its like term on the other side. So these two will cancel out to make 0. 3n plus 1n squared is 4n squared. I have a plus 3n that comes down because it didn't combine. And then 1 minus 1 just makes 0. You don't have to write the 0 if you don't want to, but you can as a placeholder for C. And that's it. That is putting in standard form, factoring out any GCFs. So now we're going to get into the process of factoring. So I know these steps look like a lot, but we actually are not going to do anything new today. This up here is day 1. Down here we have day 2. So we've actually done everything so far. We're not going to do anything new. We're just going to piece the 2 days together. So for example, we want to put everything in standard form and factor out a GCF, which we just practiced. And then we're going to label our A, B, and our C values. We'll draw an X and fill A times C into the top triangle, and then B into the bottom, which we've already done. So remember, that's this thing right here, A times C up top, B on the bottom. We'll find what multiplies to A times C up top and adds to B on the bottom, which is when we built our table and then found the correct solution to plug in. So we've already done that day 1. And then we replace your BX with the 2-factor term. So that's when we kind of broke apart the BX into the 2 pieces. So that was all day 1. Then on day 2, we started off with problems that were already 4 terms. And we learned that we would group them into sets of 2, with the ax squared plus bx being the first parentheses, and then the second bx plus c being the second. because we broke them up into two smaller pairings, we were able to factor out a GCF from each group. So we look for the GCF individually. And how we know we got it correct, this was our checkpoint right here. The terms inside the parentheses that are left over are the same for both parentheses. So that's our little checkpoint. And at the end, your GCFs will make the first factor. We're going to group those together, and the parentheses will make the second. So that was day 2. So we're going to put it all together with some very easy problems to start today. So number 1, is it in standard form? Do I need to factor out a GCF? It is in standard form. GCF, none exists, so we're good to go. So now we're going to draw our box. We're going to label our A, B, and C. I'm sorry, our X. We're going to put A times C up top, which is 1 times 3. Our B on the bottom, which is 4. Now we're going to find out what multiplies to 3 adds to 4. And lucky for us, that one's pretty simple. It's just 1 times 3. They're both positive, which means these both are positive, and 1 plus 3 does equal 4, so we've got that. And that's what we're going to use to bust the B. So x squared comes down. We're left with 1x plus 3x, because remember, these both add up to 4, so it's not changing the value. We're just breaking it into 4 terms. And then when we're in these 4 terms, that's what we learned on our second day. What can we do with these 4 terms? Well, we can group them into smaller pairs and then look for a GCF. And a GCF is something that they have in common. So if I look at this, this means I have 2 x's. This has 1 x, right? So I'm going to divide out an x from both. So when I divide out, that means it's coming out in front, and I'm left with, if I have 2 x's, I take out 1, I'm left with 1. If I have 1x, I take it out, I'm just left with the coefficient of 1. Here I have a 3x and a 3, so they don't have x's in common. So this one doesn't have an x, but they do have a 3 in common. So I'm going to divide out 3 in front. 3 divided by 3 is 1x. 3 divided by 3 is 1. So if you look, the insides are the same, which means we did it correctly. So remember, that's our checkpoint. The parentheses are the same. If these were different, then I would just have to go back and double check my GCF. I probably didn't get everything out. And so now what I do is I'm going to take my GCFs, x and 3, those came out, so I'm going to bring them out together, and what's left over goes back at the end. And that's it. We have factored a quadratic into 2 smaller equations that we will then solve. So we went from a large equation with 2 variables to 2 small equations right here. And that was the whole goal, to make this more easy to work with. So let's look at number 2. First of all, number 2 is not in standard form, so I first need to minus the 15 from both sides. I get 3x squared plus 12x minus 15 equals 0. Now, if I look for a GCF, remember, I could factor this without taking out a GCF, but these are going to be some big numbers, and if I find a GCF, I can make it smaller. So that's what I'm going to do. I'm going to take out a 3, and that leaves me with x squared plus 4x minus 5. So now this is my new A, B, and C, and I'm going to use that to bust the B. So remember, A times C up top, so 1 times a negative 5 is negative 5, B on the bottom. So the question is, what multiplies to a negative 5 adds to positive 4? Well, the only combination of 5 is 1 and 5, and in order to add to a positive 4, the smaller one needs to be negative. So negative 1 plus 5 equals positive 4. So that is what I'm going to use to break apart my B. So remember, this 3 we're going to keep to the side for a bit, but it's going to come back at the end. We're just not working with it yet. We're just working with what's in the parentheses. So x squared comes down, minus 1x plus 5x minus 5 equals 0. So remember, that was day 1. Day 2, we're going to group them and factor out a GCF. X squared and negative x both have an x in common, so that's what we take out. X squared, take out an x, is just x to the first. Take out an x, we're left with the coefficient. Here, these do not have an x in common, but they do have the coefficient of 5 in common, so that's what I'm going to take out. That leaves me with x minus 1. X minus 1, x minus 1. It's correct because we have the same insides. So then I'm just going to regroup my GCFs come together. What comes out goes out together. What's in stays in together. Now, the one thing we can't forget, that 3 belongs outside. Okay. And that's the idea of it. So nothing was new. We just put day 1 and then day 2 was right here. Okay, so what we're going to look at now is special cases. So just when something's missing. It's nothing really new. It follows the same principle. So first thing we're going to do is make sure it's in standard form. So it is, we're good to go. But we do have a GCF. And what you're going to notice is actually this one has a little bit more than our previous GCFs. This is a 2, this is a 6, so a 2 can come out, but if you look, everything has an X as well. So guess what can come out? An X. So I have 2X coming out, 2 divided by 2 is 1, squared, take 1 out, is just X to the first. 6 divided by 2 is 3, X, take out the X, I'm done. So I have no more X. Now, if I look at this, when I took out my GCF, I no longer have an X squared. I no longer have 2 variables like we did on the previous page. So before, when we took out GCFs, we still had multiple variables and we weren't able to solve yet, so we had to factor. Here, I took out my GCF, I no longer have multiple variables. So we are actually done in this special case because I've simplified a 2 variable to 2 different 1 variable equations, and we are done. Now, this one isn't going to be as simple. So this one, I have to take out the 2, but it still leaves me with an X squared, which is kind of a hard equation to work with. So what we're going to do is still bust the B. Here, we were left with just X to the first, nice and simple. Here, X squared, we're still going to bust the B. So A times C goes in the front, or goes up top, so that's a -4. B goes on the bottom, which if we look, there is no B, because remember B has the X, so this is that case where it's 0. So we think about what multiplies to 4, 1 and 4, 2 and 2. But one of them has to be negative to multiply to negative, and if you look, they're canceling themselves out, which means they have to be the same value. Right, so it doesn't really matter which way you write it. You can write this negative or this one the negative. It doesn't matter which one you put where. So what I'm going to do is bust the B, and I kind of want to make sure I don't forget about my GCF. That's going to come down at the end. But right now we're just going to break apart the middle. So I have X squared plus 2X minus 2X minus 4 equals 0. So I group. And what I need to be careful about is this minus. So we haven't seen one of these yet, but we talked about a lot of them yesterday. That minus belongs to the 2, so we want to make sure we don't draw a line through it. And now I factor out the GCF. So I take out an X, so this becomes X. I'm left with X plus 2. Now here, if the first term is negative, we always want to take out the negative. We learned that yesterday, so if this part is negative, that's going to come out in order to keep with the positive from the previous one. So -2 divided by -2 is going to give me a positive 1 inside, and that's how these are going to end up matching. If you didn't take out the negative, this would have been a negative X, which means this didn't match. So negatives always come out, and then -4 divided by -2, positive 2. And again, if you didn't take out that negative, the signs would have been wrong here. So again, if the first term is negative, always take out the negative. So now I'm going to rewrite it. My GCFs make the first, my leftovers make the second, and then I want to bring that GCF from the very beginning back down. And again, the whole goal was to take something that was X squared or something with multiple variables and break it into 2 smaller equations. All right, and that is it. We'll pause there and we'll just work on it the next day.